How to improve the steam quality. In modern industry, steam is a vital resource. It serves as both a heat source and a power medium. Steam is the invisible engine that keeps many factories running. For example, thermal power plants use steam to drive turbines to generate electricity. Other industries also rely on steam, including the chemical, food, textile, and paper industries. These industries use steam for heating, cooking, drying, and sterilization. The quality of steam directly affects production, energy consumption, and equipment lifespan. However, many companies focus only on a few things. They check if the boiler is making steam. They check if the pressure is high enough. They often overlook if the steam is dry, clean, and stable. Because of this, the boiler may seem to be working well, but other problems appear. These include pipeline water hammer, low heat exchange rates, and high energy use. Product quality can also fluctuate. The root cause is often the same: poor steam quality. As an industrial boiler manufacturer, we understand that providing high-quality steam requires a multi-pronged approach, encompassing water treatment, boiler design and maintenance, as well as operating procedures and system management. The following will explain the definition of steam quality, explore the causes of steam quality degradation, and discuss how to improve steam quality in a real-world factory environment. #Steam boiler. What exactly is steam quality? In engineering, steam quality has two main parts. This is the amount of truly dry saturated steam in the total steam mass. Higher dryness means more usable heat energy per unit of steam. If steam contains many water droplets, it may seem fine. The pressure and flow might look good, but the useful energy for heat transfer is lower. This can also cause erosion and water hammer. This refers to the impurities in the steam. Does it have too many dissolved solids or corrosion products? Does it contain non-condensable gases? These impurities affect how clean equipment surfaces are. #Steam boiler. Why do many boilers struggle to provide high-quality steam? Unstable temperature and pressure control 1. Substandard feedwater and boiler water quality 2. Unreasonable boiler structure and system design 3. Inadequate routine maintenance and operational management 4. During boiler operation, temperature and pressure can spike. Pressure and load might also change greatly. This can cause the drum water level to shift wildly. This leads to steam water carryover. Boiler water gets carried out by the steam. As a result, many water droplets mix into the steam. This naturally lowers its dryness. Substandard feedwater and boiler water quality 2. Raw water may have high hardness. It might have high dissolved solids (TDS) content. If there are no good softening, desalination, and deaeration steps, problems will appear. Scale, foaming, and corrosion will form quickly inside the boiler. Scaling reduces heat transfer. Foaming and carryover directly cause boiler water to enter the steam. This makes steam quality worse. Unreasonable boiler structure and system design 3. Some older boilers have smaller steam drums. They have simple steam water separation devices. The steam pipelines may have poor slopes. There might be too few condensate drainage points and bad insulation. Even if the original design was adequate, it is hard to keep high steam quality. This is especially true over the long term in real-world conditions. Inadequate routine maintenance and operational management 4. Heat transfer surfaces may not be cleaned for a long time. Blowdown might be done just by experience. Steam traps may not be checked for years. Operators might not focus on condensate removal and venting. In these cases, the steam system will slowly bleed in unseen ways. It might seem like production can continue, but energy use and failure costs are quietly rising. #Steam boiler conclusion. For a boiler to produce high-quality steam, it takes more than just enough pressure. It is the result of water treatment, boiler health, and operational management. You must do a good job with feedwater softening, deaeration, and TDS control. Keep the boiler interior clean and the blowdown reasonable. Combine this with standard control of operating parameters. Timely removal of condensate and air is also crucial. Ongoing maintenance of traps, insulation, and pipelines is key. Only then can steam be dry, stable, energy efficient, and safe. This will reduce energy use and failures. It will also improve the efficiency and product quality of the entire production line.